welcome to the stream. If you're new here, I'm Jared. I am a Rubyist and I run a consultancy called Supergood, where we build e-commerce websites using Ruby on Rails and a platform called Solidus. Today, though, we are doing Advent of Code problems, picking up where I left off on my last stream. Last time we had completed part 1 of day 23, but part 2 is sort of the same problem with much larger inputs. So the approach I took does not work. So let's just go over the problem before we get started here. Good, my stuff is working. So we've been challenged to a game by a crab that we previously played War, the card game with, or Combat as it was called. This crab has a bunch of cups arranged in a circle, and they are numbered. And when you go clockwise, so this is their clockwise representation, and we have to do one of these operations. For the first part, we do it 100 times. So we pick up the 3 cups that are immediately clockwise of the current cup, select a destination, which is the cup with a label equal to the current cup's label -1. Then we place the cups we've removed after that destination cup, and then we select a new current cup, which is the cup immediately clockwise of the current cup. Now, we can do that with a small input like this, like the input that we received. That's easy, that's pretty fast. However, I implemented this as just storing the ring in an array and doing a little modulo math to do the wrapping and stuff correctly. Unfortunately, part 2 is now we have a million cups, and we must do this operation 10 million times rather than 100. That makes this far too slow. And the way I did it. So we need to come up with a way essentially to do this in constant time. So regardless of the number of cups we have, we need to be able to not take more time on each step, which unfortunately the way I did it is not the case. My thought is we implement a linked list. I believe that we need only a singly linked list for this, and we also store like a lookup table, like a hash table, or it'll be a hash of the cups by their numbers, so that when we want to look up the cup that is -1 or whatever from the that has the ID that is 1 less than the current cup, we can do that in constant time as well without having to search through our linked list to find that cup. Which means we're going to have to fully re-implement this. But one of the nice things about these problems is that we can implement, we can use our original tests that we wrote for this logic and just make part 1 do the new logic as well. So that terminal. That is what we're going to do. So I started vaguely trying to optimize this, not really thinking about how slow it was. And then I think I put a put statement somewhere. I guess it's not still here. And I tested the speed, and we were going at less than 100 iterations per second with the way I've got it. So that is an absolute no-go. We cannot go that slow. Now, the one thing is, it's a little trickier to, if I implement this as a linked list, I'm going to have to do some work here to sort of, the fundamental logic of this test is fine, but I'm gonna need to change the APIs of the game and that kind of stuff. So how do we want to do this? My thought is, for now, I'm just gonna implement the our nodes as just arrays. Is that fine? Well, like the first element is the value and the second element is the next thing. Hello, welcome. So if that's the case, a game's going to need to be sort of a ring of, well, I guess we'll have a current element. That's the only thing that matters. As long as we have a reference into the ring at all times. And then our lookup table. And okay, so I'm going to say I like this this API. I think we should keep it. We might have to turn this into like a set API because we're going to actually store it as a ring instead of as an array like we have here. This might have to change like to be something like current first or something like that, but we can worry about that after. So let's see, make sure let's commit that. Too slow, not working, day 23, part 2. Okay. This is too slow. So we will still pass in this thing, but we're gonna have to build our linked list from here. So we'll still need most of this logic. This is gonna have to all change though. I'm just gonna throw it away for now. This is all, yeah, none of this stuff is not keeping it. So, what next? We need to build our linked list here that, and we'll also need to record our first, what our current cup is. So, what's the easiest way to do this? We can build it as, I guess we can just pop the first thing off, right? So the first thing, we can set it as current even. And this will be shift will take us the first element off. I don't really care about mutating it. And then we've not created the next element yet. So we'll say so now we have the previous node, and now we can start trying to build this thing up. So input.each do, and then we'll have this will be like our cup ID here. We'll say new node equals ID nil, and we then set previous node. This is linking up the nodes, and and what next? And then we set the previous node to the new node. And that should get us all the way to the tail. And then we need to say previous node, and we will set it to be current. That should work, I think. So we have a current, we have a current. That is funny that Ruby lets us like inspect that, but then gets a certain amount of depth and goes, uh-oh, we're recursing. But 389.125.389.25467 is, I believe, what we're expecting to see. 389.125.467. Yeah. So we did parse that correctly. That works. We now have our ring, but the one other thing we need is we need a reference to each of all of these IDs so that, yeah, I assume I'm not the first person who's tried to like print a recursive data or like a self-referential data structure in Ruby. So, you know, I'm not surprised. I wouldn't expect it to break, but I had no idea what it was going to do. So that's kind of funny. Now we can steal a pry now. That's going to blow up a bunch because we have not gotten that far. Now, as we're building this, doubt it works the same in IRB. Well, that's an interesting thought. Votes on what this is going to do in IRB? No? I think it's just printing the inspect, isn't it? Yeah. So this must be a feature of arrays in Ruby. You might have a maximum depth or something. No, it is. I don't know. If anyone wants to find out the answer. Oh, yeah, there you go. Sorry, I'm just gonna show that on screen. Cursive key inspect ID equals true. Okay, so as you inspect things, it keeps a hash of what it's visited. Nice, thank you, Jay Hawthorne. That is really interesting and neat to know. Huh, neato. Back to the codes. So now the other thing is I want to keep a hash that just stores all of the elements in the array so that I can do constant time lookup to find the ones I'm looking for. So I want to build that as I go as well. Call this nodes. It's not a great name, but it will do. Do you want to get it on stream? Just a sec. I'm gonna mute. It was Amy is making a sweater for Roxy, a Christmas sweater, and she needed opinions on how to sew the Christmas tree on the back of it. So now where we at? Right, we were setting the nodes in here. So we want to set nodes, and we need the prove node dot first equals prove node, and we want to do that for every single node that we add. And I think that's it. So let me take a look at make sure that worked as well. Yeah, it's not pretty, but it does all line up. We have all of our things that we expect to have in our hash, so we can do constant time lookup on them as well. Okay, so that's that. Now we just have to implement all of the logic. Easy, right? So we need to remove the 3 cups clockwise of the current cup. So step 1, remove the 3 cups clockwise of the current cup. We'll do that by taking I don't know, call these pickup cups. Picked up. Bad. I don't really care about variable names in these. You'll see a lot of single letters and stuff. Picked up cups is current. This attr accessor is not a real thing. Current dot last, right? That will get me the element after it. And then we want to take the last. So we want current dot next, or sorry, dot. Ooh boy, current. There we go. So we want to change this to point to the like 4th element away, or however you want to call that. So this is the next element. This is the element. Yes, I think that's right. Yeah, so we call it a total 4 times. That sounds right. So that works. And then we, what do we do now? We now have our cups in our hand. They have been removed from the thing. I guess we can binding.pry and just like take a look and make sure that what I just did was sensible. So if we look at current, we should now be missing the 3 cups that we should have picked up, which are 8, 9, and 1. And we are 3, 2, 5, 4, 6, 7. 3, 2, 5, 4, 6, 7. So we've successfully picked up those cups and removed them. Now we need to select the destination cup. Now there's one gotcha when selecting it, which is the destination cup could be in our hand, so we have to make sure that we handle that correctly. That means that we should just check the cups that are in our hand. So we can get their values pretty easily. So those are the IDs of the cups in our hand. It's not pretty, but it's fine. We can optimize that more if we care. Then we current. We want to loop decrementing the target ID until it fits. So we can just do a loop. Ooh, but this is where we start having to know the we start having to know the maximum and the minimum. So before we even head into this, I'm just going to record those. Get here, we can do min equals nodes dot keys dot min and max equals nodes dot keys dot max, and that just gets us the maximum and minimum IDs so we can avoid trying to look up negative cup numbers. If for example we are on current cup is 3 and 2 and 1 happen to be in our hand somehow, we can avoid continuing to loop down into negative numbers. And those values don't change, so that's fine. So we want to target equals current first, and target minus equals 1. So it's that, and then we want to do a little bounds check. Target equals max if target is less than min. That keeps us in bounds, and then we can break if in hand cup IDs, sorry, unless. Oopsie. So that should get us that, right? Now we should know where we're going. So like the first time I hit this, it should be a 2. Ooh, it's an error. Cups. Sorry. Why did I not get here? Day 23, line 111. I know my part 1, part 2 test shouldn't work, but my game test, undefined local variable or method picked on 26. Okay. Oh yeah, these. Thank you. Thank you, chat. Okay, there we go. Perfect. So this target should be 2. Target is 2. So that works. We're gonna hit it again. And it'll be some other value, which I think we can check if 1 is the right other value. 2, and then, oh, there's no way to know if we're not doing enough of the logic for it to compute that correctly. That's fine. I'm just gonna disable our tests that are just like totally not going to be working for this period, so that we're just running the test we care about. Yeah, there we go. So we've now figured out where to put them, and we just need to insert them where they go. So nodes target 1 equals picked up. So that is, oh, but we can't do that step first. We need to set picked up last 1. So this is, we need to set the tail of our picked up chunk to whatever is after at nodes.target. What am I doing? What are my fingers doing that's wrong? There we go. Last. And then that kind of looks reasonable. So if we look at current, we have 3289154667. 3289154667. That's great. That worked. And then we just need to advance current. So at current equals at current last. Now our tests aren't going to pass, but disable pry. Yeah, disable pry will stop pry from being, we'll just ignore any further invocations of pry for the process. So if you've pried in a loop or something, it is a saver. It is your savior. Or if you have a pry that's going to hit by a whole bunch of tests, but you only really care about one of them, you're done caring. Ah, exit bang. Oh yeah, to just exit immediately. Yeah, that's another option. Now, I don't know really how I'm going to assert things here. So I'm going to expose current as current.first so that some of my tests continue to work. I don't really know what to do about, whoops. Let's see if that works. Some other thing failed, but that's fine. Expected 8, actual 1. What's that about? Well, that's interesting. Let's take a little look. 167385429. I mean, it's 100% just like not even slightly the right value. Which is interesting because these are the same numbers. What? Oh, this is 100 times. Sorry, my mistake. Why do I have a test for 100 times? Do we have the... Oh, interesting. Sorry, I forgot what we had. So for the example, if the cower complete all 100 moves, it would be 6, 7, 3, 8, 5, 4, 2, 9, 4, 5, 2, 9. Is that what we got? So that's the bad assertion, but so starting with 1, it is 6, 7, 3, 8, 5, 4, 2, 9. Okay, so I would say what we have works. We just have to make the rest of it work. Unfortunately, these aren't very good tests because I was too lazy to write a way to do this assertion, because we'd have to like pull the linked list back out into an array, and then we'd have to decide what the order of the array is and stuff. And I didn't want to do that. So that's fine. Now let's look at our part 1 solution. In fact, let's switch to running part 1, because if we can get part 1 working with this code, then seems like should be fine to do part 2. And I think we want to like expose, we also want to expose just the cups, because we're going to need to, it's just going to grab it from, or what we care about is the 1 node, right? So let's just return that. Cool. So for, right, I remember how I did this. So we do n times and sure, we grab the cups. We're already on the 1 index. So we're just building a string of them until we hit the 1 again, right? So until sorry, cup stuff. So until current is cups, I don't know that, I guess I could, I think. That's a clever idea, Hoth. Yeah, we should try that. We should try that and see if we can fix our specs after, because that's kind of a neat idea. I like that. Current equals cups. Until current equals cups. I didn't print anything out. What happened? That's the new one. Okay, so that's not good. There we go. No, was that my actual answer for part 1? 895732446. Sick. Okay. So we can uncomment this test. Oh, and remove the binding.pry. Lovely. Okay, so we have part 2 working with a linked list. Now we can try and illustrate part 1. Now we can try and make part 2 work. Switch my binding to run part 2. And this is junk. We are going to use the exact same game class. Stop parameterizing that. However, I do need something different. Do need a point to inject my extra million elements or whatever. So new game input. I mean, I guess I didn't need to. Oh. Put a whole bunch of random ends in there just for fun. And input here. In fact, this doesn't need to be parameterized because that is available to us. And what did I mess up? Game class. Where's game class reference? Oh, I didn't change it. Yeah. Cool. And conveniently, this is also running one for 10 million. So we're going to see how long mine takes. An amount of time that finishes. That's cool. So now we know we can run it 10 million times. So now we just have to get the right result out of it. And there's a result method. And what we need for part 2 is the, I have no idea what the significance of any Twitch emoji are, but I like this cute dog. The 2 cups that will multiply the IDs of the 2 cups. Oh, sorry, we haven't added our extra inputs. That's what we're missing. We have not yet. So we need to say game.new, but we're not just passing in input, we're also passing in yeah, so I do know that one. And this is, what am I typing into? Why is this? There we go. Oof. I guess I don't need to wrap that. Oh yeah, no, I do. So now it should not take significantly longer, other than it has to create a 1,000,000 element array. So there'll be a bit of extra time for that, but it gets to the end. Okay. But we just need to multiply game.cups is our first one. So we're multiplying 1.last.first times 1.last.last.first for our result. And let's re-enable our test. Oh, it passes. Sick. We did 10 million iterations of that manipulation on this ring in, not long. Who said Ruby's slow, you know? Ruby is slow, but it's fast enough. All right. Day 23, part 2. Yeah, nice. Very nice. I am going to grab some water. I will be back in like 1 minute and we will start day 24.